Okay, so this is the probability where we review a little bit, and then we get into the new stuff, which is about Venn diagrams. You know, those two circles that overlap? All right, so to start with, I did this problem completely wrong last hour because I went like this, 4 feet by 2 feet, so I said that the total area was 8 feet. Was I doing it wrong yet? No, I was fine. Then it said that the hole was 6 inches across. And I was all Mr. Smart because I was like, I'm not going to use 6 because it's supposed to be the radius. So I used 3 for 3 inches. And that screwed up the whole problem. Can you think of why? Remember.
Are you writing?
This is in... Thank you. I am writing on that one, but I'm not writing on this one. Sorry about that. Hold on a second. 4, 2... And this, I used 3 inches right here. And I felt like I was so smart because I didn't get suckered into using 6 inches. But what's wrong? This is going to come out totally wrong. If I do pi r squared using that 3, it will be totally wrong. It won't even be close to a percentage. What am I doing wrong? Do you have any idea? What's wrong with using a 3 right there? Yes?
It has to be in feet.
It has to be in feet. See, you can't do one part of the problem in feet, one part of the problem in inches. So what the heck is 3 inches but in feet? It's 3 out of what? Come on. 3/12. This is the part where you will need a calculator. I am okay with you using your iPad for now, but I think it's dumb. I really do. Because on the test, you can't use your iPad. You're going to have to know how to do it on the calculator. And there's also cool things that these calculators can do that your iPad can't. Like reduce fractions. You have 54 over 128. This can reduce it. Your iPad can't. So, it is your life, but the day of the test comes and you don't have a calculator, I'm not going to cry for you. I strongly recommend that you get a calculator. I even said I would give you one for my garage if you explained why you cannot afford one. Not why you can't afford it, but explain that you can't, like, monetarily afford it. And I do usually check with moms and dads to make sure that that's not just a story. Because usually, kids can get a calculator if they've asked. And if you can't, and I have had that, just talk to me. I'll get you one. All right, that is 3 out of 12, and you should have divided it on a calculator by now. Be ready to be called upon. Teo, what did you get when you divided 3/12?
0.25.
All right, that is correct. So 0.25, and then I got to do pi r squared. So it's pi times 0.25 squared. That's going to take a little work. Everybody put that into your calculator, and this is our answer. Pi r squared over the total area of 8. Cell phone, goes away. And you haven't started yet. What's on? That goes away. You with us. You're not on the right page. That's not okay.
Oh, is this one? Can you pick up the
It's pi r squared, so it would be the 1/4 has to be squared. So it's here. I'll write it out better on the screen up here. One-fourth squared. Now, I personally would have used 0.25. Here, I'll write that out. It'd be 0.25 squared all over 8. Pause for a second when you guys crunch those numbers.
0.024.
There it is. Now, what does that mean? That means there's only a 2% chance you're going to hit that hole when you toss the beanbag. Do you get that that means out of 100 beanbag tosses, you're only going to hit it twice? I mean, that's why it's really hard to play that game. I mean, a random chance comes out to 0.024. You're aiming, I know, so that should improve it, but you know, it's pretty hard to hit that hole. Okay, that is the right answer. Now, if you didn't get that, you had trouble typing this, and I encourage you to ask me, but the biggest mistake is kids often forget to get this final answer and hit enter and get that answer and then divide by 8. And some kids just forget to divide by 8, but you know, not many people do that. Okay, I'm going to give you another one. I think this is important enough to try. So let's say it's like this, and I'm going to do that same inches and feet thing. This is 3 feet by 5 feet, obviously a total of 15 feet. And I'm going to get that on this screen here. 3 feet by 5 feet, a total of 15 feet. So then, what if I have a circle that has a radius of 6 inches? Hint, don't use the 6. Figure out the probability of hitting this spot. I'll pause for a second and give that a shot. So you guys should have used 0.5 for this, not 6 inches, 0.5 feet for the radius. Do you remember the formula for the circle? Sage, you know the area of the circle formula?
Is it pi r squared?
It is. And what is our radius in this case?
0.5.
Yep. So I go pi times 0.5, which is the radius, squared. All divided by 15, because the whole area came from 5 times the 3 makes the 15. So everybody, see if you can get that in your calculator. I know some people are good at this and some people aren't. In this moment, I want you to compare with the kid next to you. I know there's a hand up, and I'll come back and ask that person what their question is, but right now, everybody put this in your calculator and see what you get. Pausing. Yeah, so if you use 3.14 for this, and Sam, what's the other one? 3.14 times what? This, 0.5 squared. It's all divided by 15. What'd you get for 0.5 squared? Okay. I'll pause for a second. 0.785 on the top over 15. And then if I divide that by 15, who are the lucky people who had 0.052? Raise your hand if you had 0.052. You are correct. What the heck does that mean? 52%? No. What does that mean?
5%.
About 5%. You move the decimal over 2 spots, and you get about 5%. Okay. Yes?
Do you have to do the 0.5 squared, or can you just like type in your calculator pi and then like 0.5 squared to get the answer? So I got the same thing.
If you type in your calculator the pi button, okay,
Yeah.
and then I think you don't have to say times, and then you immediately say pi, and then you say 0.5, and then the squared button, there's a button that has squared on it. I think it'll work.
Yeah, it does.
Okay.
I was just wondering.
It's just, I'm not used to putting in pi first. I mean, I know pi r squared probably is first, but usually you say like 2 pi, and then I know it knows to multiply. But now I know if you type pi 2, it also knows to multiply. Yay. Okay. All right, moving on. What's your goal for today? Venn diagrams. Event A, both A and B, or just only B. All right, I want to do a Venn diagram that you guys can relate to. Everybody make 2 circles off to the side, and I want you to put dog, and I want you to put cat, and then down here, I want you to put neither. I'm going to pause for a second while you actually draw that. dog, cat, neither. So here's our data for this class. We have 12, 2, 0, and 3 out here. Would you copy that down, please? Now let's say that before class started, I put a gift card and glued it underneath one of your desks. Okay? What's the probability that I happen to hit a dog person? A person who likes dogs. Now you're probably wondering, should you use the 12? Or should you use the 2? Or should you use both of them? Do you think these people would describe themselves as a person who likes dogs? They probably would. If you just asked them, do you like dogs? They'd say, yeah, I got a dog. Just because they also have a cat doesn't mean they also don't like dogs. So both of these. So my probability would be 14 out of 17. I want you to think about how I got that. You had to have both put the 12 and the 2 together. And a total of 14 out of 17. Do you understand what I just did there? Okay, let's do one more. Imagine on that same diagram, I now want to ask you this question. What's the probability I get a person who has a dog and a cat? When you put a P in front of something, that's what that means. Probability of dog and cat. And is the 2. You should have said 2 out of 17. Raise your hand if you had 2 out of 17. Okay, good. Next, this one, I'm going to ask you to compare your answer with the person next to you, and we're going to see who's right. Some people are going to know how to do this, and some people aren't. This either means and or. I want you to write this symbol, and then take a guess whether you think that means and. Like, you know, dog and cat. Does this mean dog and cat, or does it mean dog or cat? You can't really know this unless you have learned this before, but do you know what this symbol means? Does that mean and, or does that mean or? Talk to the kid next to you, come up with what you guys think, and I'll tell you the right answer in a second. Does that mean and or or? It's a math symbol.
It's an or. It's like a logic gate.
All right. Do you get that there's a danger when people don't really know and the first person says one thing? Everybody tends to be like, oh, it's that. All right. The answer is and. Think of it like an end in the word and. A-N-D, you know? That is an and. There's another name for it called intersection. And these are small answers. I want you to take notes on that. That means and, it means intersect, and it means small. Why? Imagine that the Highway 7 and the Highway 101 all have a bunch of cars on it, right? But who is on Highway 7 and Highway 101? The people that are in the intersection. You've heard of the intersection, right? It's where they overlap, you know, where the two roads overlap. So only the people that are in here, on the inside here, let's put a blue one in there. Those people that are in there, they're in the intersection of the two roads. They're on both roads. At that exact moment, they're on both roads. Does that make sense to you? That's called intersection, and that's that symbol. Here's the other symbol. And the way I'd like you to write it is with an O-R on the top of it, because take a wild guess what it means. Or. Okay? That symbol means or. Do you get there's a lot of people on Highway 7 and there's a lot of people on 101, but if I said all the people who are on 101 or 7 are going to win, that's a lot of people. Ors are a big answer. And they officially mean this word, union. The other one in that intersection, this one means union. The word that I want you to associate with it is or, and those are big answers. Let me give you an example of this probability in class. Let's say I said, you win. This is going to be a big answer, you'll see. If you have a dog or a cat or a fish or you wore clothes to school today. See if I say or enough times, it just gets to be everybody. Okay, so or gets bigger and bigger and bigger and bigger every time I say or. You win if this or that or that or that or that. Ors are big answers. Okay, so try to remember the ors are big. It's counterintuitive. It's a small word, and it seems like the answer should be should be small things. But it's not. Or is a big answer, and it means the union. So why do I care so much about that? Here's a new Venn diagram for you. Everybody copy this one down. Piano and car. I am guessing that some of you can drive a car at this point, even if it's with just a provisional, like you've got a learner's permit. And I'm guessing some of you have some sort of piano. It could just be an electronic keyboard at home. And some of you don't have either one, and you're going to be there. Raise your hand if you're in the piano only. You got a piano, but you don't have your learner's or your permit yet. 1, 2, 3. Okay. Raise your hand if you got a piano and you've got some sort of license. It's either your full driver's license or you got the permit. 1, 2, 3, 4, 5, 6. Okay. And then raise your hand for just car. You got some sort of car permit, but you don't have a piano of any kind. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And last but not least is you haven't got any of those things. No car, no piano, none of that. Okay. One person. Thank you. Okay. So then, add them all up. This one adds up to what? 20. What's the probability that if I were to turn around, throw my keys backwards, and see where they land underneath somebody's desk, in other words, random person's desk, what's the probability I'd get a person who has a piano? Now, some people are going to use 3, and they're wrong. Corey, what should you use for the piano? Not just the 3. Also the 6. Both of those have pianos. So what's the total, Corey? 9 out of the 20. 9 out of 20 piano. Do you get how I got that? A lot of people will say 3. If I'd have said, what's the probability the person only has a piano, then it would have been 3 out of 20. Okay? Make sense? Okay. How about if I said piano, union, car, like puck? Do you know what that means? Piano, union, car. Do you feel like that should be a big answer or a small answer? Do you feel like it should be and or? Which symbol was this? Is this the union or the intersect? Do you remember that? It's the or. Can anybody just see the little O and the R sitting up here like you saw it in your head? That'd be good if you were one of those kids, because it means or. And ors are small answers or big answers? Big. This is a big answer. So what you want to do is look at your Venn diagram and find the big answer, which has got the 3 and the 6 and the 10 all together. And so that makes 19 out of 20. Remember, ors are big answers. All right. So, I think that's enough. I think we should go on to actually talk about Venns changing into probability diagrams. So, I want you to get to this slide notes. It looks like this. See the one that has one arrow, goes it from one probability, or sorry, from one Venn to another Venn? Okay, get on that page, and then turn your iPad my way so I know you're still with me. Excellent, except for one person. Thank you. I believe you wouldn't have turned it unless you were. Okay, so here we go. I'm going to give you some numbers for the probability and the chemistry. This is ones that I'm making up that's more realistic for Minnetonka. Almost every single kid in here is going to be in both. So I think if I asked you out of 20, 18 out of 20 of you have both chemistry and Spanish. We're going to put Spanish here and we're going to put chem here. Everybody label it that way. Spanish on the left circle and chem on the right circle and 18 in the middle. 18 out of 20 of you are probably in both. Not all of you are in Spanish, of course. Some of you are going to be in like different languages than that, but most of you at this point, I think I could say could speak a language. I could be wrong. Let's say there's one person here, 0 people here, and 1 person here. And here's my question. If there's a total of 20 people, what the heck do you do to make it into a probability Venn diagram? Don't overthink this. What do you think should go here? Yes?
1 out of 20?
You are correct. And good at math, I can tell. Nice job. 1 out of 20 there, and once you get that pattern, everybody's going to know it's 18 out of 20 here, 0 out of 20 here, and 1 out of 20 on the outside. Now, if you get decimals for that, this would be 5%. If I took 1/20th, that'd be 0.05. 0.05 here. And 18 out of 20, I think that's 80%, isn't it? Can anybody help me with that? Is it? Or is, no, it's 90%.
90.
Thank you. 90% on the middle. And this spot 0 is always 0, of course. And last but not least, the outside edge here, 1/20th, that's 5%. Okay. What's the difference between this and this? One's the probabilities, one's got numbers. Do you get the numbers can make the probabilities? All right. Last thought. Let's say I only had this, and then I said, what if there were 10 people polled? It was actually 10 people. Could you get it back to like, oh, so it's 90% of the 10? So how many people were in the middle? You'd multiply this, how many people there were, times this. And you could say, oh, there was 9 people. 10 times 0 is 0 people. 10 times this is not 5 people. What the heck does that mean? That means half of a person. It kind of broke my analogy, so that I shouldn't have picked 10. I should have picked 20. I'll pick 20 people. So I take 20 and you times it by 0.05, and then that would be 1 person. That'll work out a lot better. So there was 1 person here, 1 person here, 18 people here, one person here, 18 persons here, 0 people here, and 1 person there. Okay, I apologize, it's been a little bit of a weird lesson today. I think, though, we're ready to actually start the homework on this. Let's just make sure. Get to this slide right here. We're almost done. Stay with me. Okay, probability math. Don't overthink this, but don't underthink it. Obviously, the 4 or the 3 might be involved, or maybe both of them. Write down what you think the answer is right here, and I want you to turn and compare with the kid next to you and see if you guys agree on the probability that you get a math student. Pausing. All right. So, I hope you knew that both of these people were in math class. So together it's 0.7. Raise your hand if you had 0.7. Those guys were right. 0.7. Okay. Now what if they said probability only math? Would that have changed your answer? If they only took math, then only this one would have been used. If they say only, then you don't include the middle. They didn't say only. Let's go to this one, everybody. We're almost done. PS. What do you think that means? Probability of science. Do you think we include both the 0.3 and the 0.2? Yes, you do. What if they said probability only science? Then you would have only picked that one. Okay. So in this case, though, we'd include both, and the answer would be 0.5. All right. Math, but not science. That's the same as only math. What do you think the answer to that one was again? 0.4 is correct. All right. Math and science. Think big answer, small answer. Or is the small word but a big answer? This is the bigger word but a small answer. You should have said 0.3. Who is thinking 0.3? Just give me a feeling for who's still following. All right, good. And let's leave the or one. Is that supposed to be a big answer or a small answer? It's a big answer. Or is the biggest of them all. In fact, it's all of those. These people all took math or science. I know the middle one's confusing, but if you asked them, did you take math or science? They'd be like, well, yeah, I took them both. All of those. 0.9. That's also called union. Unions are big. Unions want to be big because if your union is small, it doesn't work really well. So, all right. This one, it's hint saying the intersection is 0.18. Where do you think we should put the intersection of 0.18? Where do you think that goes? Where's the intersection part? It's like the two highways that overlap each other. Yeah, the middle. And the middle is the most powerful place. Once you figure that out, the rest of the problem's way easier. Okay, next. A is 54. You know what everybody wants to do? They want to put a 54 right there. Wrong. You do not put the 54 right here. Why not? Well, because these two spots together add up to 54. So you're going to take 54 minus the 0.18 and put it there. So I'll do that for you. 54 minus the 18, and you get 36. 0.36. 0.36. Okay. We made it, boys and girls. There is a Schoology quiz. Now, I'm not saying it's super easy, but I'm saying at least you can start it right now with me, and some of you will finish in class, some of you won't. Finish it as homework. That's the 15-minute warning. That's all I got for the lesson for today.